Okay, so learning about oxidation numbers, it's because we are looking at transfer of electrons and we use an oxidation number to find when something is oxidized or reduced. Okay, because remember, oxidation is a loss of electrons because you have oil, and then reduction is a gain rig. So remember, you have your oil rig to remember. Oxidation is a loss, reduction is a gain. So now electrons are negatively charged. So if I lose electrons, I'm losing all the negatives, which means a loss of electrons would become more positive. So if an oxidation number becomes more positive, I know that oxidation has occurred, whereas reduction is a gain of electrons. So we're gaining the negative charges. So reduction means it becomes more negative. So if the oxidation number gets more negative, then I know reduction has taken place. So oxidation numbers, there are a set of rules for us to follow, and we can find the oxidation number of anything by using those rules. And once we find the oxidation number, we can look at how an oxidation number changes in different compounds, and then we will know which is oxidized and which is reduced. And we can also use our oxidation numbers to balance redox equations, okay, by balancing that number of positives and negatives. So what we're going to look at is the rules, and then we will look at how we use those numbers. So our rules for oxidation numbers. The first one is that an element that is not in a compound, meaning it's not bound to something else, is always going to equal 0. Anything in group 1 is always going to be plus 1. Any element in group 2 is always going to be plus 2. Fluorine is always negative 1. Hydrogen is always positive 1, except when it's with a metal hydride. So for example, NaH, because then the Na gets the plus, so then the hydrogen becomes minus 1. Oxygen is always minus 2, except in peroxides, where it's going to be plus 2. And then the number of an ion is always going to be its charge. The sum of oxidation numbers in a compound must always add up to 0. The sum of oxidation numbers of an ion must add up to its charge, and the more electronegative number will always get the negative oxidation number. So if we're going to put those rules into practice and we look at some examples. So if I start with this first one, N2, this is nitrogen bound to itself, but it's not bound to anything else. So it's an element that is not in a compound. So we say its oxidation number is 0. Then if I look at my next one, H2S. So I'll always look for the element that I know. And I'm told hydrogen is always plus 1. So that means that hydrogen here is plus 1. But there's 2 of them. So that means 1 times 2 means its overall charge is plus 2. And now this is a compound that has no charge. And I've said the sum of the oxidation numbers of a compound is 0. So that means that all the oxidation numbers in here must add up to 0. So far I have a plus 2. So in order to get this to equal 0, that means that the one that's missing has to be minus 2. because plus 2 minus 2 would be 0. So that means that sulfur has an oxidation number of minus 2. So then if I look at the next one, H2SO4. So now I have 3 different elements. But I do know that hydrogen must still always be plus 1. And there's 2 of them. So that means it's plus 2. But then I also know from my list, oxygen is always minus 2. So I've got oxygen there as minus 2. And there are 4 of them. So 2 times 4 means minus 8. Okay? And now since this is a compound, the whole thing must still equal 0. So now I've got minus 8 plus 2. And now I need to find what's that missing number to get this to equal 0. So what I'm going to need is a plus 6 to get that to equal 0, because plus 2 plus 6 minus 8. So that means that sulfur is going to be plus 6. And you can see there the sulfur was minus 2. So those oxidation numbers are different. And that's what's going to happen in an equation when I go from one compound to another, and I can then figure out which is oxidized and which is reduced because of the different numbers. So then if I look at the next example, now I have NO2 minus. So again, I look for the thing that I know, and I know that O2, well, O must be negative 2, and there's 2 of them. So that means minus 4. But now there's a charge, and I've said the sum of the oxidation numbers of an ion equals its charge. So that means I'm saying that this whole thing must equal minus 1. So now I need to find what I'm going to add here to get the whole thing to equal minus 1. So I've got minus 4. So what I need to do is plus 3 to equal minus 1. So that means the nitrogen is plus 3. So then if we look at the next one, NaNO3. So again, there's 3 different elements, but I do know 2 of them. I know that Na is in group 1, and group 1 elements are always plus 1. So I have plus 1. I know that oxygen is always minus 2. So the sodium, there's only 1 of them. So that's plus 1. But the oxygen, there's 3 of them. So 3 times 2 means minus 6. There's no charge to that compound. So the whole thing must equal to 0. And now I need to find the missing number that will get the whole thing to add up to 0. So I've got plus 1 minus 6 means this has to be plus 5 to get that to equal 0. And as you can see again, the nitrogen here is plus 5, but over here it was only plus 3. So they're not always the same. So that's the one thing you've got to remember. Only the ones in the rules will always be the same. So then if I look at my next one, I have Fe3+, and my rule says the oxidation number of an ion always equals its charge. So its charge is 3+, which means its oxidation number is plus 3. Then I have got ClO3-. So the one that I know is oxygen. It's always going to be minus 2, and there's 3 of them. So 2 times 3 is minus 6. The whole thing must equal its charge. So it must equal minus 1. So now I need to find what can I add to my minus 6 to get it to minus 1. And that's going to be plus 5. And then if I look at my next one, I have NaHCO3. So now I have 4 different elements, but there are 3 of them that I already know. Na is in group 1, and group 1 is always plus 1. So there I have plus 1. So now There's only one of those, okay? Hydrogen is always +1. So that's also going to be +1. And oxygen is always -2, and there's 3 of them. So -2 times 3 is -6. The whole compound has no charge, so it must equal to 0. And now all I have to do is find my missing number. So I've got +1, +1, -6. So I'm going to need +4 to get this to equal to 0. And there's the one that I'm missing. So that's always what we're going to do. We have to know our rules to find the oxidation numbers of the things we don't know. So there will always be enough of the ones we do know to find that missing one in examples like that. Okay, so then, as I said, we're going to find the oxidation numbers, but in an equation, we're going to use those oxidation numbers to be able to find which is oxidized and which is reduced. So if I have an equation like this, okay, I need to find the oxidation numbers of each of those things, and then I'm going to see the differences. So Fe3+, it's an ion, which means its oxidation number is its charge. The same for I-, Fe2+, and I2 is an uncombined element, so that must be 0. So now I have oxidation numbers for each thing. And now I can look at where I've got iron to iron and iodine to iodine. So I can see that iron goes from +3 to +2. Okay, so if I go from +3 to +2, I am getting more negative. Okay, because I'm decreasing in those positive numbers, and getting more negative means more electrons. So now, if I'm getting more electrons, remember, oxidation is a loss, but reduction is a gain. And when I get more negative, I'm gaining, which means that this ion has to be reduction in the equation. And then if I look at the iodine, it went from -1 to 0. So now going from a minus number to 0 means it's getting more positive. And if it's getting more positive, then it has to have lost those electrons. Okay, because we're losing the negative numbers, and a loss of electrons is oxidation. So that means the iodine is getting oxidized. Okay, so that's how we're going to use our oxidation numbers to find reduction and oxidation. So if we look at the next example, in the next equation, I have copper oxide, and I can find my oxidation numbers because I know that oxygen is always -2, and there's only one of them. Okay, the whole thing must equal to 0 because there's no charge, which means that then the copper has to be +2. And then if I look at the next one, I always look for the one I know. Hydrogen must always be +1. And there's 3 of them, so that's +3. The whole thing must equal to 0, which means that the nitrogen has to be -3. Copper is an element by itself, so it has to be 0. Nitrogen is an element by itself, so it has to be 0. And then water, in any equation like this, we don't have to worry about because it is not involved in the redox reaction. So we only look at the elements that are not hydrogens and oxygens. So now I've worked out my numbers. So now I can see copper is going from +2 to 0. So it is getting negative. And if it's getting negative, it means it's gaining electrons, which means it has to be reduction. But then the nitrogen is going from -3 to 0. So -3 to 0 means it's getting positive. And if it's getting more positive, it means oxidation. Okay, so that's what we're going to do if we're asked to find when something is oxidized or when it's reduced. Okay, but the other thing we can also do is use the numbers to balance an equation. So if I have an equation like this, okay, that has ions in it, it's quite tricky to balance when we're dealing with those ions. So we use our oxidation numbers instead to get our balancing numbers. So I first thing need to do is work out my oxidation numbers of everything that I have. Okay, so following our rules, for our first compound, the one we know is oxygen, which is -2. There's 4 of them, so that makes -8. The whole thing must equal its charge, which is -1. So now, in order to get to -1 from -8, I need to +7. Iron is just an ion of 2+, so its oxidation number is its charge. Okay, same for the hydrogen, but we don't have to worry about the hydrogens and the oxygens just yet. We only find our main compounds. So then Mn2+ is its charge, so that's +2, and iron 3+ is going to be +3. Okay, so now I've worked out my oxidation numbers, so now I can look at what happens with the Mn and what happens with the Fe. Okay, so starting with the Mn, it goes from +7 to +2. Okay, so that is a change in oxidation number of 5 because it's going down by 5. From 7 to 2 means my change was 5. My iron is going from +2 to +3. So that is a change of 1. Okay, because I'm going just from +2 to +3. So now in order to balance an equation, I need to balance the change in oxidation number. So I need to look at what the change is, and I need to get the changes to equal. So on the one side, I have a change of 5, and on the other side, I have a change of just 1. So I need to get this change of 1 to get equal to 5. So in order to do that, I need to take this and times it by 5. Okay, and this one I'm just going to times by 1 so that they both equal 5. So that means everything here that I've used in my arrows needs to be multiplied by 5. So it's going to mean 5 of those and 5 of those. And everything here gets multiplied by 1. So that means just 1 of those and 1 of those. Okay, so now that I've balanced those main numbers in there, now the last thing I need to do is balance if I have any charges and waters. So now I've got an H plus on this side. So I need to balance the charges of the H plus by looking at how many charges I have on one side. Okay, so here I have a negative charge. So there's just one of them. So it means I have 1 minus there. But now I just added 5 of those 2 pluses. So 5 times 2 means now I have plus 10 over there. On this side, I have 1 of my plus 2's. Okay? And I have 5 of the plus 3's. So 5 times 3 means now I have plus 15 over there. So plus 2 plus 15 means there's a total of plus 17 on this side. And minus 1 plus 10 means there's a charge of plus 9 on that side. And now I need to get this side equal to that side. So I need to say, what can I add to plus 9 to get it to equal plus 17? And what I find I'm missing means I need plus 8 to equal my plus 17. Because plus 9 plus 8 is going to be plus 17. And then those are going to be the same. So here, where that plus is, means I need 8 of them to get that to equal. So now I've got 1, 5, and 8 on this side. On this side, I've got 1 and 5. So now my last thing that I need to just balance is the water. And it's got the hydrogens on it. So all I need to do is look how many hydrogens are here. And there's 8. So how many do I need here to make that 8? So there's already 2 of them, which means I just need 4. Because 4 times 2 is 8. And then the H's are balanced. So there I have now balanced my equation with my ions. So the important thing to remember is you're just going to look at what we have in our elements and our changes. And then you get the changes to equal. Then you do the charges if there's any H pluses. And then you do the waters for the last step. And that will then give you a balanced equation. So that's all we need to do with oxidation numbers. Find the oxidation numbers, see which is oxidized and reduced using them, or balance the equations.